Hello participants, I invite you to lecture 2 of micro irrigation engineering subject. This lecture is on fundamentals of fluid mechanics and its application in micro irrigation engineering. This particular lecture we are just exposing you to the different terminologies which are dealing with the fluids, mainly water. We will be using basic equations in micro irrigation engineering. So, the fluid mechanic concept are being dealt. This is a very brief lecture we on fluid mechanics aspect, which will be discussed. You have been given in your other subject, fluid mechanics subject, where you might have been taught in details about the fluid mechanics part, but here it is a briefly we are talking. So, which will be directly relevant to micro irrigation. In this particular lecture, we are dealing with the properties and types of fluid, pressure and its measurement, kinematics of dynamics of fluid flow. So, this will be discussed. Now, when we talk of fluid mechanics, so fluid is a substance which deforms continuously under the action of shear stress regardless of its magnitude, and this can be a gas or it can be a liquid. When we talk of fluid mechanics, it is the branch of science which deals with the behavior of fluid at rest as well as in motion. So, fluid can be in the position which is at the rest position, or it can be in the motion. We can classify fluid mechanics in 3 component. So, one classification when we say fluid statistics. When we say fluid statistics means when fluid is at rest. Water is stored in the tank, is fluid means it liquid is in a rest position. So, that is a fluid static, and we are finding out what is the head of water, how much is the pressure at this water depending on the depth of water, whether it is below the soil. When we are talking groundwater, there also we are talking about the amount of water available in the well or the so depth of water which is at the rest position in a reservoir, in a tank, it is fluid statistics. When we talk of fluid kinematics, so fluid is in motion without considering the force, and the fluid dynamics means fluid is in motion when we consider the effect of forces. So, effect of forces with flow, when we are means this is basically fluid dynamics when we say flow through pipe and flow through a deformable boundary. Pipe it is a fixed boundary, but when it is a deformable boundary, so there are forces also working, and then the water is also means flow is also taking place. Now, there are different properties we come across, these different terminology we come across when we are talking about fluid. So, one is density, and density is given by mass per unit volume, and the density of water is considered as 1000, and it is expressed in kilogram per cubic meter. A specific weight, when we talk weight of fluid per unit volume of fluid. A specific weight of water is 9810, and the unit is expressed in force. So, this is N, that is a Newton per cubic meter. A specific gravity, it is the ratio of weight of density of fluid to the weight density of standard fluid, that is your water. So, which the specific gravity of the water is 1. Viscosity. So, viscosity, it is there are two types of viscosity. One is the dynamic viscosity, another one is the kinematic viscosity. So, viscosity, it is a measure of resistance of fluid flow as a result of intermolecular cohesion, and then for water the dynamic viscosity, it is 1 into 1.14 into 10⁻³ Newton second per square meter is the unit. Kinematic viscosity, it is the ratio of the dynamic viscosity to the density of the fluid, and the value of for water, it is 1.14 10⁻⁶ meter square per second is the unit. Surface tension, it is used basically when we are dealing with the the soil water tension, when we are talking about the how much water it is held by the soil particles because of the forces of surface tension. So, tensile force acting on the surface of a liquid that is in contact with the gas or other liquid, it is expressed in Newton per meter. Capillarity is the another phenomena. The water moves through the capillary forces, through the capillary motion. So, when there is a say water table, that is a saturated zone, and from the saturated zone to the root zone of the plant. So, water movement, it takes place through the capillary motion. So, rise and fall of the liquid surface in a small tube relative to the adjacent general level of liquid when the tube is held vertically in the liquid. This is a general generally it is defined, but it is applicable when there is a saturated soil, and from the saturated soil water moves from the saturated media to the unsaturated media, and that is the capillarity action, it takes place. Types of fluid, these fluids can be given by ideal fluid, it can be real fluid, Newtonian fluid, non-Newtonian fluid, or ideal plastics. So, these fluid, when we say ideal fluid, it is incompressible, having no viscosity. Practically such fluid does not exist. Ideal fluid, this is the case which you see here, that means it is just you can see the this is the rate of demarcation, that is you are seeing here is ideal. This particular part, it is known as a ideal fluid. A real fluid having some viscosity, and all fluids are considered as a real fluid. Newtonian fluid, when we say means it is a real fluid in which the shear stress is directly proportional to the means the shear stress. So, this particular part when you are drawing there is a straight line, you see here a straight which line passes through the 45-degree line between the rate of deformation is nothing but the your stress. So, this is shear strain, this is the shear strain and this is the shear stress. So, when we have plotted and then 45-degree line when the slope is equal to 1, this is your Newtonian fluid. Non-Newtonian flow when it does not follow this particular graph, and ideal plastic it is in which the shear stress is proportional to the rate of shear strain and shear stress is more than the yield value. So, this is the case of your ideal plastic. Pressure, we are using this particular terminology when the fluid or water flow take place through the drip irrigation pipeline, and we are measuring how much pressure is in the pipeline or how much is the pressure at the drip system is to be operated, what is the pressure at which the sprinkler system should be operated. So, pressure is a important point, and this is why I am discussing you in this particular lecture. So, it is a pressure is defined as the amount of force exerted by fluid on any boundary it is in contact with. So, pressure is given by force per unit area, it is given by Newton per square meter, and then the pressure is measured or it is expressed in different ways. Gauge pressure, sometimes we say absolute pressure, sometimes we say negative pressure, that is a vacuum, and sometimes we use differential pressure. So, there are different terminologies which are used, and when we say gauge pressure means it is the reference to atmospheric pressure. So, water level measurement or in pipe hydraulics we use gauge pressure. Absolute pressure, when we talk of the reference is a vacuum, and then it is means it is used in measuring the barometric pressure, and for many meteorological operations we do use absolute pressure. Vacuum, when we say, means pressure is below atmospheric pressure, and there are pumps which are used to measure the vacuum pumps, or there are say in when we are talking about the soil water tension or soil water concept when we are dealing. So, tensiometer is used. So, tensiometer is using the concept of the vacuum, or when we are using the Venturi system. So, Venturi system also the pressure reduces, means it becomes negative pressure, then only the Venturi means it will suck the water from this one. So, fertigation system we use vacuum type of conditions. So, vacuum is used, and differential pressure meant measuring the difference between two pressure port readings, and that is used for the measurement of the pressure across the filter. Filter means your drip irrigation filter I am telling here, that is used, or means for monitoring the pressure at different points in the pipeline. So, that is a differential pressure which is used. Now, when the water is moving in a pipeline or it is in a pipeline, how much pressure it is water is available. This is simply a piezometric tube which gives the what is the pressure available. So, H refers to the pressure in the piezometric tube or in the pipeline. When we are taking the U tube manometer, so U tube manometer it gives that how much is the pressure available in the pipeline. So, manometric if there are, suppose this is the water and then another one is your mercury or alcohol it is used. So, there we are using a U tube manometer and find out the how much is the water pressure it is available. So, this delta H means the pressure available, the difference here between these two points, this pressure is your manometric pressure between the 2 points. There is a differential manometer, it is also used. You can see here water fluid is flowing and then this is used. So, you are taking the measurement means the at this limb left limb what is the water level available, and at the another right limb you are getting the difference between the these levels are used for this one. And then there are different other measuring the pressure by using the gauges. So, this is aneroid, this is your Borden gauge pressure, and then you are using the another pressure gauges. So, like this there are, this is the front view and this is the rear view of the your pressure gauge. So, these kinds of pressure gauges, these are being used to monitor the pressure, liquid pressure or gas pressure. Kinematics of the fluid flow. Fluid kinematics deals with the motion of fluids without considering the forces and movements which create the motion. So, methods of describing fluid flow motion, one is Lagrangian description that tracks the position and velocity of individual particles, that is used in case of Lagrangian description. Eulerier description, a flow domain or control volume is defined by fluid flows in and out, means how much is the fluid it is entering in the control volume and how much is the fluid which is going out of the control volume. So, this difference particularly when we are talking of the conservation of mass at that particular point, we are using the Eulerian description, mostly commonly used in the fluid flow. These flow types of fluid flow we discuss here. One is the steady state flow, means the velocity component it is independent of time. So, that it becomes your steady state flow. Unsteady state flow, it is the means it is a function of time. When we say it is a function of time, so means dV by dt means the first derivative of the velocity with respect to time is not equal to 0. When we call it as a uniform flow, it is means the velocity does not change with space, means with when we are taking a two section, particularly open channel flow. In open channel flow we considered uniform flow. So, the example is your Manning's equation is the example of uniform flow formula, where we consider that the velocity it is independent of the space of velocity as well as other properties, the discharge, the pressure with respect to time between two sections it is remains same. And the non-uniform flow, when the dV by dl is not equal to 0. Laminar flow, it defines the state of flow, where the laminar means your the ratio of the inertial flow to the viscous flow that gives that. So, Reynolds number is less than 2000 is considered as the up to 2200 it is considered as a laminar flow, and then the value it is given that when the Reynolds number goes more than 2000 is turbulent flow, and in between these two there is a transitional flow. Compressible or incompressible flow, that is the another category of the flows, and these are being dealt. The flow can be one dimensional, two dimensional, three dimensional, depending upon the particular material and through which the flow takes place. Accordingly, these properties, these types of flows, they are defined: rotational flow, irrotational flow. So, where from the flow is taking place. Continuity equation, it is following the principle of conservation of mass, and you are seeing here two sections. Say we are considering a pipe flow. So, one section where the diameter of the pipeline is at the section 1 is like this, and then when you see the diameter of the pipeline is this one. So, velocity component and as well as the area it is different. So, we can say at the section 1 the density of this density, area and velocity that can be given at section 1 as rho 1 v 1 rho 1 a 1 v 1 equal to rho 2 a 2 v 2. So, 2 refers to the section 2. This is applicable, this particular equation is applicable for compressible and incompressible fluids. Dynamics of fluid flow. Fluid dynamics deals with the motion of fluid considering the forces causing the flow. So, these could be forces in fluid flow, and so what are these forces? One is the gravity force, means when we are talking about the Froude number. So, gravity force it is important. When we are talking about the pressure force, means the flow is at the rest height, at what force it is working. So, means the pressure gauge which I was telling you, at what pressure the water is flowing into the pipeline. So, pressure force is considered. Force due to viscosity, that is means when we are talking about the how much is the viscosity of the fluid. So, particularly this is more when we are dealing with the viscous material where viscosity is important. So, Navier-Stokes theorem, or when we are adding fertilizer with the water and then fertigation takes place. So, forces due to viscosity is considered. When we talk about the turbulent force, means your inertial force is more than the viscous force, then turbulence takes place, and then compressibility. There could be different situation when the compressibility takes place, but here in our case we are taking the incompressible flow. So, equation of the motion that deals with the, means when we are using Reynolds equation of the motion, forces due to compressibility is neglected. When we talk of the Navier-Stokes theorem, forces due to turbulence is neglected, but other forces are prominent. And when we talk of the Euler's equation, we flow assume ideal and 0 viscous force take place. Bernoulli equation, it is one of the form of the energy equation, and then it is assumed that the flow is inviscid or frictionless, flow is steady, and then flow is incompressible. The flow is considered along the same streamline, and when you are considering the Bernoulli principle, you are taking the section 1, this is the pipe flow you are taking that. So, 1 this is the section inlet section of the pipe, and this is the throat section of the pipeline. Mainly you can see this is the case of a Venturi meter. Venturi meter, it looks like the same, it follows the. So, here at the section 1 the area, this is your area vector, this is the velocity vector, and this is the pressure part. So, at the point 1 and 1 it is given by A 1 V 1 and P 1, and at point 2 at that is your throat section. So, when the area reduces from A 1 to A 2, means diameter of the pipeline it has reduces, this that has caused the increase in the velocity, and that has changed the pressure component, and this pressure it means it has reduced because of increase in the velocity. So, this is what it is explained by the Bernoulli equation, that the velocity head v square by 2 g plus this is your elevation head z, and this is your pressure head, that is equal to constant when we are taking two sections. So, we can write v 1 square by 2 g equal to z 1 plus z 1 plus p 1 by rho 1 equal to v 2 square by 2 g z 2 plus z 2 plus p 2 by rho g. So, and if we assume this is in the same plane, means this is at the same level. So, v 1 square minus v 2 square equal to v 2 minus v 2 this is equal to p 2 minus p 1, that is. So, this becomes your this will come in this form, that is how the pressure difference it takes place. Continuity equation is defined by the partial differential form of this equation, that is the velocity in x direction partial means velocity in x direction delta u by delta x plus delta v by delta y. So, in the differential form, this continuity equation is given by this form, that is in x, y and z direction. We in the algebraic form, this continuity equation it is given by a 1 v 1 equal to a 2 v 2, or just now in previous case we have given rho 1 a 1 v 1 equal to rho 2 a 2 v 2, when we are considering the density component are different, the area component is different and velocity component is different, but the both the side it becomes equal. So, that is the continuity equation. Navier-Stokes theorem is defined by these equations, where you can see the force means this particular, let me just discuss this part, the rate of change of momentum, that is with respect to time, del by del t is given by rho u, that is the momentum part, plus the this is your gradient, that is your one means your direction, that is rho u capital U. So, this is the velocity component in your I, j and k, or I, j and w, that is in 3 dimensional form this velocity it is given, and then that can be given by change in the pressure head in x direction plus the viscosity multiplied by this derivative, second derivative of the velocity component, that is del square u, plus the body force. This particular component is the body force F the rho into F x. Similarly, in y direction it has been given. So, Navier-Stokes theorem it is describing the flow when the density of the liquid and the flow is incompressible, that can be considered. Now, there are different units which are used in fluid problems, and particularly, so one can use these units and convert it into the. So, normally SI unit is used, but if the problem we are given in FPS systems, then this can be converted to other systems. So, length, see length it is given from 1 meter to 1 kilometer like this, and then it can be equivalent to different units, feet, centimeter, millimeter and miles. Similarly, the volume units it is expressed in liter, meter cube, feet cube, and which is equivalent to gallons or liter. So, this is already available. Area it is expressed in acre or hectare. So, they are equivalent, these values are available. Pressure we are expressing, sometime we express in kg per square centimeter, which is equivalent to 10.3 meter of the water column. So, this is a value which is used in when we are operating the sprinkler system. This is the value, means your kg per square centimeter when we are using it in sprinkler system, drip irrigation system, micro irrigation system, or there we are using. When we are talking about the pressure in atmosphere, normally this is used in soil water concept, when we are using the water held by the soil particle, that is the negative pressure. So, that is expressed in soil moisture in atmosphere, or these are the other unit which you are using. We also you find out the discharge. So, different units of discharge either in meter cube per second or in liter per second, these values these are used. So, for this particular topic you refer these books for getting more details. I have just discussed in a short about, so that this particular concept it can be used in micro irrigation subject. So, we discussed in this particular lecture what are the different types of fluids. We discussed about the how to measure the pressure measurement, differential pressure as well as absolute pressure. So, these, and then we also discussed different types of fluid flow, kinematics of the kinematics or dynamics of fluid flow. We also discussed about the continuity equation, Bernoulli equation, Navier-Stokes equations, we discussed on that. Now, in the next coming lecture we will be discussing about soil water concept. Thank you very much.